Okay, so we can now look at 1D kinematics questions. In the first part of introduce kinematics. Let's just do some questions. Alright, so these are the questions that we are going to do in this part. So question 1 is saying derive each of the following equations of motion using algebra or calculus. So the first one is v is equals to vo plus at. So you can either use algebra or calculus. So for all these equations here, I'll use algebra and calculus, and then you can choose whatever you're comfortable with. Then you'll be able to use that same method. Alright, so let's start with the first one. So the first one is v is equals to vo plus at. So this is the equation that has been given. We can use algebra or calculus to come up with this same equation. So if I use algebra, so to use algebra to come up with this equation, all you need to do is you have to remember the definition of acceleration. So how do we define our acceleration? Acceleration was defined to be the change in velocity over the change in time. So the change in velocity over the change in time will give you your acceleration. So this simply means our acceleration is equals, we know that change in velocity is simply the final velocity minus the initial velocity over the change in time, which is simply t, because t minus t initial, and t initial is simply 0, so you still get t. So from here, when you get to this step, all you need to do is make v, or the final velocity, to be a subject to a formula, then you're done. So for me to make the final velocity to be a subject to a formula, all I need to do is you cross multiply, so you get v minus vo is equals to at. So to make v a subject to a formula, you get whatever is here and take it on the other side. So what you're going to get is v is equals to vo plus at. So this is the equation that we get. I think this is very simple. You can't fail to understand that. So this same equation, you can also use your calculus to come up with this same equation, and I believe it's also very simple. So now, when you're using our calculus to come up with this equation, what you need to remember is the definition of instantaneous acceleration, which was defined to say instantaneous acceleration is given by dv divided by dt, a small change in velocity over the small change in time. Now, the equation that we are told to come up with is starting with a v. So this simply means we need to come up with a v from whatever we have here. So if a is dv over dt, the v that is in front of the equation can only come from dv. So that's why I need to make dv a subject of the formula. So if we cross multiply, I'll get dv is equals to a d dt. So this dv here simply means small changes in velocity. And then dt here simply means small change in time. So therefore, for you to find the total velocity from dv, all you need to do is integrate, because integration will give you limits, and those limits, and you'll be able to find the final using the limits. So that's why you need to introduce the integral on both sides. Since we're saying dv is a small change in velocity, so for you to find the total velocity from those small changes, all you need to do is integrate, and using integration you'll be able to come up with the limits, and those limits will help you to find the total velocity. That's why we are introducing the integral on both sides. Even this side here, we are integrating with respect to t, and then on the left hand side we are integrating with respect to v. So meaning on the left hand side, our main focus will be on integrating whatever is before the dv, and then on the right hand side our main focus will be on integrating whatever is before the dt. So what is before the dv is what we are going to integrate on the left hand side, and whatever is before the dt is what we are going to integrate on the right hand side. So if you ask yourself what is in front of this dv, the number that is in front of this dv is simply 1, and we all know that 1 is a constant. And how do you integrate a constant? So if you remember, since we all know that integration is simply the reverse of differentiation. And how do you differentiate? For example, if you've been given 2x, if you differentiate 2x, you get 2, isn't it? So simply means if I've been given 2 and they tell me to integrate it, it simply means just adding the x, isn't it? This simply means for me to integrate this one, I'll get 1v. The same way, if I integrate 2 with respect to x, I'm getting 2x. If I integrate 1 with respect to v, I'll get 1v. Okay? So therefore, if we integrate this one here, I'll get v. And then the limits will be from the initial velocity all the way up to the final velocity. And this is equals to, even on this side here, we are focusing on what is before the dt. And what is before the dt is simply a. And we all know that a is constant, so a is also a constant. And how do you integrate a constant? We said whenever you're integrating a constant, you just multiply that constant with the letter that you are integrating with respect to. Same applies here. We multiplied 1 by the v, that's why we got the v. The same here, when integrating 2 with respect to x, our answer was 2x. So this simply means when I integrate this a with respect to t, I will get a t, and the limits will be t0, which is 0, to the final time, which is t. Okay? Then from here, we can now apply our calculus where we said the upper limit minus the lower limit to find the total velocity. So meaning we are getting the upper limit, replacing in the equation that we have, minus the lower limit, you also replacing in the equation that you have. So when you replace in the v in this v here, you still get v, minus when you replace the vo in the v there, you get vo is equals to, you also do the same here. You replacing the t in this equation here, you still get at minus, you replacing this t here in this equation, you still get a times 0, since we are saying the initial time is 0. So therefore you have v minus vo is equals to a at. And then from here now you can make v a subject to the formula. So your v is equals to vo plus a at. So that's how you can use your calculus to come up with the first equation of motion. So I think this is very simple. Okay, so we can now move on to the second equation, which is x is equals to xo plus vot plus 1 over 2 at squared. So even for this one, you can either use calculus or algebra to come up with that equation. Okay. So the equation is x is equals to xo plus vot plus 1 over 2 at squared. So if you use your algebra, the formula that we focus on is the formula for average velocity. So we use the formula for average velocity, which is equals to total displacement over the time taken. So in this equation that was given, what is the subject to the formula? It's x. That's the displacement, isn't it? So therefore we need to make displacement the subject of the formula. So if you make displacement the subject to the formula, therefore you get your change in the displacement is equals to the average velocity multiplied by the time. Okay, so therefore our change in x will be given by, how do you find the average velocity? If you have the initial and the final. So if you are finding the average velocity of a and b, what would be the average of a and b? We said a plus b divided by 2. So same applies. For me to find my average velocity, I will say the final velocity plus the initial velocity divided by 2 multiplied by the time. But from the first equation of motion, we already know the value of v. Here they are saying v is equals to vo plus at. So whenever there is v, we can replace vo plus at. So we are saying where v is equals to vo plus at. And where is this coming from? Our first equation of motion is the one that is having v to be equal to vo plus at. So we can now replace this where there is this v. So what you're going to get is a change in x is equals to, where there is v, you replace in vo plus at plus VO divided by 2 multiplied by the t. Okay, so you can collect the item. So a change in x will be given by, if you add this and this, you get 2VO divided by 2 plus AT divided by 2, and this is being multiplied by the t. Okay, so therefore our change in x will be given by this and this will cancel out, so you get VOT plus 1 over 2 AT squared. So we've just simply multiplied our t throughout. But we all know that change in x will be given by the final minus the initial, which is equals to VOT plus 1 over 2 AT squared. So therefore, your x will be given by XO plus VOT plus 1 over 2 AT squared. So that's how you use your algebra to come up with that equation. So this same equation, you can use your calculus to come up with this same equation. So let's also use calculus. Okay. So if you are using calculus to come up with this equation, you just focus on the first equation of motion, which was V is equals to VO plus AT. So this is the equation that we are going to use to come up with the second equation of motion. Now, if you notice, for me to use calculus, I need to have something like my dx, dv, dt, something like that. That's the only way our calculus is going to work. So what are you going to do? Okay, I know that, okay, this v here can be found by saying dx over dt. This is equals to VO plus AT. This is what I wanted. I wanted to get to a point where I have my dx, my dt. That's now where the calculus comes in. So I know that this v here will be given by dx over dt, so I've just replaced. Where there is v, we've replaced dx over dt, which is equals to VO plus AT. And then from here we can make dx a subject to the formula. So this will be given by dx is equals to VO plus AT, and then this is being multiplied by dt. So if you remember in the first equation of motion, we said for you to get rid of this dx, you need to integrate. For you to get rid of this dt, you need to integrate. So you integrate this side, you also integrate this side. So how do you integrate now? We said whenever you're integrating, you focus on the number or any letter which is before the dx or before the dt. So here we are focusing on the number before the dx or the letter before the dx. Here we are focusing on anything that is before the dt, which is VO plus AT. So this simply means here we have our 1. We are integrating our 1 with respect to x. So whenever you are integrating a constant with respect to a certain letter, it simply means you are just multiplying that constant with the letter you are integrating with respect to. So here we are going to get 1x, but I'll just write x, and the limits are the initial displacement to the final displacement, which is x. And then here now we are integrating with respect to t. So if you are integrating with respect to t, and VO is a constant, so a constant you multiply it by the letter for it to be integrated. So meaning this VO here, if you integrate this VO with respect to t, you get VOT. Okay? And then if you integrate AT with respect to t, what are you going to get? What are you going to get? So if you remember the power rule, there was that one, if you have AX, how do you integrate AX? This was, if it's to the power n, it's the same as you saying AX n plus 1 over n plus 1. So if you integrate this t with respect to this t, what you're going to get is AT 1 plus 1 divided by 1 plus 1. And then the limits are t0, which is equals to 0, and t. Okay? Why are we applying this? Because we have this t and we are